Welcome back to Applied AI Engineer. This episode is a turning point. For the last few episodes, Atlas has been a chain, a fixed pipeline that retrieves documents and answers from them. Today we give Atlas something new, the ability to decide what to do next and to take actions in a loop. That's what makes it an agent. We'll build the agent loop from first principles, learn the React pattern, create a tool registry, and then rebuild the same loop as a real LangGraph agent. By the end you'll have a minimal agent that reasons, calls a tool, observes the result, and keeps going until it's done, and you'll see its genuine reasoning trace, step by step. Let's pick up exactly where we left off. Over episodes 5 through 8 we built retrieval-augmented generation. Atlas loads your documents, finds the chunks relevant to a question, and answers grounded in them. Last episode we sharpened that with re-ranking and citations. But notice the shape never changed: retrieve, then augment, then generate, the same 3 steps, in the same order, for every single question. That fixed shape is exactly what we're about to outgrow. Here's where a chain breaks. Imagine asking Atlas, what is the API rate limit, and how many requests is that over 5 minutes? Answering needs to different actions. First look up a fact in the docs, then do arithmetic on it. A chain can't do that. It has no way to choose between looking something up and calculating, and no way to loop back and do a second step once it has the first result. The shift from retrieval to action is the shift from a fixed pipeline to a model that plans its own next move. Here are the 2 shapes side by side. On top, the chain, retrieve, augment, generate, a straight line, no choices, no loop. It's perfect when you already know the path. On the bottom, the agent, it reasons about which tool to use, acts, observes the result, and then loops back to reason again with that new fact in hand. The agent doesn't follow a fixed path. It builds the path one step at a time. That loop, reason, act, observe, repeat is the whole idea of this module. Let's prove the wall is real. Here's our chain from the RAG episodes, stripped to its bones: retrieve, then answer. We ask a question that needs both a fact and arithmetic on that fact. The chain will happily fetch the rate limit document, but there is simply no step in it that can multiply. It can't add 1 because its shape is fixed. Watch it fall short. And there's the gap. The chain returns the right document, 60 requests per minute, but it never answers the second half of the question, the 300 over 5 minutes, because it has no way to act on what it retrieved. This is the precise moment a chain stops being enough. What's missing is a loop and a choice of tools. Let's build exactly that. Let's make the agent loop concrete. It has 4 moving parts: a reasoning step where the model picks an action, the action itself where a tool runs, an observation where we read the result, and a stop condition. We'll build each one in plain Python first, so nothing about agents stays magic. This is the diagram to burn into memory for the rest of the course. A task comes in. The model reasons, which tool, with what input. It acts, the tool runs for real. It observes the tool's result. Then, crucially, it feeds that observation back and reasons again, now better informed. Round and round, until the model decides it has enough to give a final answer. The model never computes the fact itself, it decides, the tool produces the truth, and the loop carries the result forward. Everything else this module builds is a richer version of this one cycle. Concretely, 4 pieces. First, a registry of tools, the agent's hands. Second, a model step that reads the situation, reasons about it, and chooses either a tool to call or a final answer. Third, the loop that runs the chosen tool, observes the result, and feeds it back. And fourth, easy to forget but essential, a stop condition. An agent that can loop can also loop forever, so we always cap it with a step budget. Let's build the tools first. The first tool is a calculator, and notice how carefully it's written. We never call Python's eval on text the model produced. That's a remote code execution hole waiting to happen. Instead, we parse the expression into a syntax tree and walk it ourselves, allowing only numbers and the arithmetic operators. So 60 times 0.18 runs fine, but anything trying to import a module or call a function simply can't. A tool is an attack surface. Treat every one as untested input. We'll go deeper on tool safety next episode. The second tool is our Atlas knowledge base, the same product docs we embedded back in episode 5, now wrapped so the agent can call it. Here it's a tiny keyword retriever so the focus stays on the loop rather than the search. Next episode we promote the real RAG retriever embeddings, re-ranking the works into a tool exactly like this. That's the key insight. Retrieval becomes just one action the agent can choose, sitting right alongside the calculator. The registry ties the tools together. It's just a dictionary mapping a name to a callable plus a one-line description, and that description matters because it's exactly what the model reads when it decides which tool to use. The run tool helper dispatches by name and, importantly, catches errors and returns them as text. An agent should never crash because a tool failed. A failed tool is simply an observation the model can reason about and recover from. We'll lean hard on that in episode 10. Before wiring anything into a loop, we test the tools on their own. The calculator turns 60 times 0.18 into 10.8, and a search for rate limit returns the right document. These are deterministic, same input, same output every time. That's deliberate. The model supplies judgment, which varies, but the tools supply facts, which shouldn't. Get your tools rock solid in isolation first, then let the agent orchestrate them. Now the brain. The pattern that powers almost every modern agent is called React, short for Reason plus Act. The idea is simple but powerful. Instead of answering in one shot, the model interleaves thinking with doing, one step at a time. Let's understand it, then drive it for real. React breaks each step into a thought, an action, and an observation. The model writes a thought, it's reasoning about what's needed. Then an action, the tool it wants and the argument. We run that tool and hand back an observation. The model reads it, thinks again, and either takes another action or, once it has what it needs, emits a final answer. Interleaving reasoning and acting is what lets the model correct course mid-task, something a single big answer can never do. Here's one real React step laid out. The thought, I need the GST on 60 at 18%, and I must use the calculator rather than compute it myself. The action, call the calculator with 60 times 1.18. The observation, 70.8, the genuine tool result, fed back into the next thought. And the final, the total monthly cost per seat including GST is $70.80. Each block is small and inspectable, and that trace is your single best debugging tool when an agent misbehaves. Here's how we turn a chatty model into a controllable agent, a strict contract. We tell it to emit exactly one JSON object per step, either an action or a final, and nothing else. And we explicitly forbid it from computing or recalling facts on its own. It must go through a tool. That second instruction is what stops a capable model from just answering the math in its head and skipping the loop entirely. Constraining a free-form reasoner to structured output is the trick that makes it safe to drive in code. Now the genuine model decision. We have no API key in this environment, but the Cloth Code command line tool is already authenticated, so we shell out to it. We pass the React contract as a system prompt and the current task plus scratchpad on standard input. The model replies with one JSON step, and we slice out the JSON object. This is a real model reasoning, not a script pretending to. In a production app, you'd swap this one function for an SDK call returning structured output. The loop around it is identical. And here's the entire loop, under 20 lines. Each iteration, ask the model for a decision, print its thought, and if it's final, return. Otherwise pull out the action and its input, run the tool for real, observe the result, and append both to the scratchpad so the next reasoning step can see them. The for loop with max steps is our stop condition, 5 tries, and we give up gracefully rather than spin forever. That's it. That is an agent. Let's run it on a real task. Atlas costs $60 per seat, with 18% GST on top. What's the total? Watch the genuine trace. Step 1. The model thinks it needs the calculator and refuses to do the math itself. It calls the tool, which really returns 70.8. Step 2. It reads that observation, recognizes it has the answer, and emits a final. This is a real model reasoning over real tool output. The loop, the tool, and the decision are all authentic. Step back and appreciate what just happened. We never told the program to calculate. The model decided that, on its own, from the task and the tool descriptions. It looped exactly once, then stopped when it had enough. And the whole thing is laid out as a readable trace. When an agent does something wrong, picks the wrong tool, loops too long, hallucinates an argument, this trace is where you'll see it. Logging the full reason act observe sequence is the single most valuable habit in agent engineering. Our handwritten loop is great for understanding, but real agents grow branches, retries, memory, and human approvals. Hand-rolling all that gets messy fast. So from here on we build agents with LangGraph, the framework that makes the loop a first-class object you can inspect and extend. The good news, it's the exact same loop, just expressed as a graph. Why reach for a framework now? Because LangGraph models the agent as a state machine, nodes are the steps, edges are the transitions, and a shared state object flows through. The loop or stop decision becomes a conditional edge, a routing function. And once your agent is a graph, you inherit the hard parts for free in later episodes, checkpointing so it can pause and resume, streaming of intermediate steps, and human-in-the-loop interrupts. We get all of that without changing the underlying loop. First, the state and the nodes. The state is a typed dictionary that flows through the graph, the task, the running scratchpad, the latest decision, the answer, and a step counter. The reason node calls the very same model step function from our handwritten agent and bumps the counter. The act node runs the chosen tool for real and appends the observation to the scratchpad. Notice each node just returns the fields it changes. LangGraph merges them into the state. We're reusing our tools and our model step verbatim, only the wiring is new. Now the wiring, and this is where the loop lives. From the start we go to reason. Then the conditional edge, the route function looks at the state and returns either act or finish. That's the model choosing to keep going or stop. The act node always edges straight back to reason, and that single backage is the loop. Finish edges to end. Compare this to our handwritten for loop, same reason, act, observe, stop, but now it's a declarative graph that LangGraph can run, checkpoint, and visualize. The structure has become data. Here's the compiled graph. Start flows into reason. From reason, the conditional edge branches. If the model wants a tool, it goes to act, and act loops back to reason. That purple edge is the cycle. If instead the model has a final answer, or we've hit the step budget, reason routes to finish, which flows to end. It's the identical reason act observe loop we wrote by hand, now a genuine state machine. Every richer agent we build for the rest of this course is more nodes and more edges on top of this skeleton. And here's the LangGraph agent on a two-tool question. What's the rate limit, and what is that over 5 minutes? Watch it loop. Reason, then act with kilobyte search. It really looks up the docs. Reason again, then act with the calculator. 60 times 5 is 300. Reason a third time and finish. Two different tools, chosen in the right order, each running for real, the result of one feeding the next. That's an agent solving a problem no fixed chain could, and it's the same loop, now riding on a framework we'll grow all the way to the capstone. One provider note, because the loop is universal. With Anthropic's native tool use, the model returns a tool use block, you run the tool, and you send the result back as a tool result, the same reason, act, observe cycle, just expressed in the messages format. OpenAI's assistants and responses APIs run essentially this loop on their servers for you. And every agent framework, LangGraph, LlamaIndex, CrewAI, is a different wrapper around it. Learn the loop once and every one of these is just a new coat of paint. Let's recap. You now understand the leap from a fixed chain to an agent, a loop where the model reasons, acts through a tool, observes the result, and repeats until done. You built a tool registry, drove a genuine React loop with a strict JSON contract, and then rebuilt it as a LangGraph state machine, capping it with a step budget so it stays safe. Next episode we make Atlas a true tool-using agent, real tools, web search, a calculator, the full RAG retriever, even SQL with proper schemas, argument validation, and graceful recovery when a tool fails. The loop stays the same, the hands get much stronger. See you there.